Part 2. Here we go again. Molly, just for an instant in the just for an instant, it goes off the table. The velocity is only in the x direction. So guess
during that instance,
Yeah.
so 0.
right, because it's v sub at the very first instance. So this zeroes out. Ladies, I need you to pay attention. So you'll be doing this yourself in a minute. All right, Hannah, your turn. What is acceleration in the y?
Is it? I have no idea.
9.
Oh, is it? It's just 9.8.
Right,
Okay.
and then?
And then t squared.
All right, tippy tap, give me time in this one. Now again, this is fake data. Is it showing up, the board work showing up okay, Aaron?
Oh, I got a negative.
Oh no, I got a negative 2.
A negative, okay, well let's make this negative and then it'll be positive.
Ah! There's non-negative answer. So
2.3.
Anyone get 2.3?
I got 0.37.
It's probably wrong.
Or 0.38.
Let me try it again.
Yeah, I got 0.37.
I got 0.39.
Seriously?
0.389, 0.37, which is it? 0.38?
You can do, yeah, sure.
All right, 0.38. It's something close to that. So if it only did this fall in about a third of a second, almost 4/10 of a second. Yes.
So in our own problem, we should have the 9.8 as a negative, so it's not. Okay.
All right. Acceleration is downward, so we can live with it. What do I do with that t, Morgan?
Back into the top.
All right, we're going to put it back up here. So if you would do the honors, Morgan, put in 0.50 equals the second velocity.
I got
Times
1.3.
Pardon, 1.3 is velocity 2.
Yep.
Does that make sense that velocity 2 is lower, where's velocity 1, than velocity 1? Does it make sense? What did we add on this side that we didn't have on the other side?
Friction.
Right, doesn't it make sense then it would slow it down? So, all right, the final thing is the hardest thing, so please lend me your brain. We got to, oh, that was water. I'll get it later. Let me finish, it's okay. Just sit down, it's just water. We talked about dogs and stuff, water's nothing. Alright, so over here is where we got to compare these two numbers. So little bitty math lesson. How do I compare two numbers? Suppose it takes me 4 seconds, say it's 6 seconds to run around the room. So I run around the room 6 seconds, and that's deplorable, you know. So I'm old and fat and out of shape. So I go on a diet and I work out and I sleep and all that good stuff, and then I can run around the room in 6 seconds. I can't do anything about the old part, but I can do the rest about the rest. So how do I compare those two numbers? What we do in Mathematica land is we take them and we make a ratio. Did John miss some of that?
No, you just can't see
You
it.
can't see it on the board.
All right, I'll move over here. All right, can you move it over here? All right, John, what we're doing is we're comparing 6 to 4. This is a math lesson. So I ran around the room in 6 seconds, and then later I got in shape and I ran around the room in 4 seconds. So what we're going to do is we're going to take the lower number, divide it by the higher number, and that is called a ratio. We can write it as a percentage, and to do that, it'll come up as a decimal when you tap that in, so it's like 0.67, something like that. And then you want to change it to a percentage, multiply it by 100, and you'll have 67%. But now you have to subtract that from 100% to see what the percentage difference is. So 100, there's the word difference. I'm looking for the percentage difference. So what is that?
33.
33, okay. So this was a 33% change in data. I went down, I improved my score 33%. So I want you to compare these two numbers, V1 and V2. So I'm going to do, well actually I'm not, what we're really comparing is kinetic energy. Kinetic energy in the second, and divide, because that's the lower velocity, and this is in the first. So we have 1/2 mv2 squared and 1/2 m. I'll have to write this on the board for him later.
Yeah,
So-
you can't
all right,
see
and
it.
so the 1/2 and the m's cancel. So all I have to do is compare the square of the velocity number 2 to the square of velocity number 1. So 1.3. Somebody square that for me and divide it by 1.7 squared. Can you get that, Brendan?
Oh, yeah.
What percent or what decimals that yield?
0.58.
0.58. So that's 58%. So that's going to be the energy that remains.
Oh, wait.
That's the energy that remains, but we want the work of friction. So it's going to be what if this energy remains and we start it with 100%, we're going to subtract to find the work of friction. So 42%. I made this data up. That's an awful lot for friction to a Rob, but let's see if it's realistic or not because you have the real McCoy data. So this is the work of friction. And I'll explain that again. While you're working, I'll explain that again to Jonathan. So could you shut that down, Annabella? And Jonathan, part 3 for you. I'll do that again where you can see it.
We can talk.
Just turn that off. Okay.